Hello guys, thank you so much for being with me in another artificial neural network tutorial video. We talked about neural networks and the algorithms related to them. We said that if we have larger networks, we need more advanced techniques such as data preprocessing. We said that choosing the activity function itself is very important. Now we want to see the steps of solving a problem using neural networks. A CIFAR-10 problem contains 60,000 images with 3,072 dimensions. We consider 50,000 data for training and 10,000 of them for testing. We must perform preprocessing on the data. If necessary, we will set the standard deviation to 0 in any direction. First, we need to determine the architecture of the neural network. This network must have an input layer with the size of 3072, and also because we have 10 classes, we must have an input layer with 10 neurons. We must have an output layer with 10 neurons. But the number of hidden layers and the number of neurons in these layers will be a little trial and error, something like trial and error. For now, we start our work with a layer containing 50 neurons. First, we must initialize the parameters. Here I have initialized the biases with 0 value, and we have also used the random function to initialize the weights. We have considered the standard deviation to be very low, and as a result, the dispersions will be very low. First, we calculate the loss function, the cost function for the data of the training set. Here we use SVM for this. Okay. Our model takes the input size of 3072 from us. The number of outputs is 10. We also specify the number of hidden layer neurons regarding the regularization coefficient. We consider this coefficient to be 0 at first. It is clear that if we consider a coefficient greater than 0 for this lamp, the value of the loss function will be more than 2.3. In gradient descent, there is a very important parameter called learning rate. We have already said that finding the optimal value for this hyperparameter is very time consuming. At first, we perform the steps of finding the right value for this hyperparameter on a small set of data. If overfit happens, we can hope that this alpha can be suitable for larger sets. For now, we have considered the regularization coefficient to be 0. We have considered stochastic gradient descent as the optimization method for now. For now, we do not reduce the learning rate in each iteration. This section, verbose is true. This section, verbose is true, also means a print of information for me about training. If this network is a good network and can learn 50,000 data, it must be able to learn 20 data. That means overfit should happen. We can see that the value of the cost function decreases in the first iteration. Later iterations are more important. You can see that in the end, the value of the loss function is very, very low. Fortunately, overfit has happened, so it may work well in large data sets. Now we need to apply the training to the entire training set. Different superparameters may be in one algorithm. Different hyperparameters may be in such an algorithm. alpha and lambda, we initially focus on the learning rate. For this, we consider a very small value for lambda. For now, our focus is to find a suitable interval for the value of alpha. We do not need to find an exact number. Validation data is part of trained data. Based on this validation data, we want to determine the appropriate amount of hyperparameters. First, we consider a very large interval for the values of alpha. First, with a small number of alpha, we calculate the value of the cost function. We see that we have almost no movement. That is, the value of the cost function does not change. This change is very, very small. In this way, we understand that the value of alpha was very small. Now we consider a much larger value for alpha. For example, we will try the value of 1 million. The value of the cost function increases. In Python, NaN means that this number is so large that overflow has occurred. In 64 bits of the space of decimal numbers in Python, a certain amount of numbers can be placed. So this means that the value of the cost function is too large. So we understand that the amount of alpha was very, very large. And now we try alpha with a value more than the first attempt and less than the second attempt. Again, we see an increasing trend in the cost function. So this alpha is still very big, very large. So we understand that the appropriate interval is between the value of the first attempt and the third attempt. This search process is called coarse to fine. That is, in the first stage, we consider the number of epochs to be very small in order to reach a range of hyperparameters. Once we get the range, we can increase the number of epochs. After finding the proper interval for alpha, we can find the proper interval for the second hyperparameter. For example, we test for a maximum of 100 times. At first, we set them randomly. I have created the classifier. I have initialized the model. I have used a few epochs to save them, to save time. For optimization, I have used a better method than stochastic gradient descent. Because the number of epochs in each repetition is small, it does not take much time. You can see that where the accuracy was 0.412, the learning rate was 1.4. We choose the best answer compared to the others. In these iterations, we check the learning rate and understand that probably the optimal value of alpha should be between 5 to 10 in power to 5, 10 in power to 5 and 10 in power to 4. Actually, minus 5 and minus 4. You can see it here. So we got the interval between 10 in power to minus 5 to 10 in power to minus 4. That is, we find a smaller interval for the optimal value of alpha. The worrying thing is that one of these optimal results is very close to the border of this interval. For this reason, to be sure, it is better to consider values slightly smaller than 10 in power to minus 4. In general, we may have tens of hyperparameters, and the regular search may take a lot of time, and so it is better to use the same random search. You should pay attention to a point in neural network training. During this tutorial, you should definitely monitor the value of the cost function. The general trend of this function should be downward. But why is it a downward swing? The reason is to use stochastic gradient descent because an estimate of gradient descent algorithm is used. If the learning rate is low, the slope of this graph is reduced and we can reach the optimal solution, but with more iterations. If the learning rate is high, initially the slope of the graph is too high. But from one point on, there will be no improvement, and it is even possible that the value of the loss function will increase. The meaning of this figure, this chart, is that in the first iterations, no learning has occurred. The reason could be the very low learning rate. Likewise, accuracy and loss can be plotted for both training set and the validation set. When we had a very good performance on the training data but not on the new data, there will be a big gap between these two graphs, and overfit will happen. This is where the overfit will happen. To solve this problem, the number of data can be increased or regularization can be used. But if the difference between the two graphs was small, it means that this model can include more neurons. That means we can still make the model stronger, more powerful. For example, increase the number of layers or increase the number of neurons. You are constantly updating and changing weights. The ratio of this change to the previous size of these weights must be within a certain interval. If it is too much or too little, too low, you should know that there is something wrong with the workplace. Okay, have a nice time. I highly recommend you not to miss the upcoming videos. We will have just, I think, 3 other videos, and they will contain very useful and beneficial tips for you. So I highly recommend you not to miss them. Have a nice time.